Hi. We need to check which of the given words contain consecutive letters that are identical. Let's start with a word that does have a duplicated letter, that is the lowercase l. The easiest way to go about this is to do a pairwise comparison. So we want to compare every letter with its neighbor. For that, we use the dyadic form of the reduction. So this is an equal reduction, and this is a pairwise equal reduction. We go over windows of size 2 and compare. So we can see that there are 4 pairs. 1, 2, 3, 4. And the third pair has the same left and right, so they're equal to each other. We're not actually interested in knowing where they are or how many there are. We just want to know whether there are any. So we want to ask, are there any? Which is an OR reduction. So we're putting OR between these. So we're saying 0 or 1 or 0. And that gives us 1. Yes, they are. If instead we try world, then we don't get any because there are no duplicated letters. Okay, this solves the basic part of the challenge, but there are a couple of catches. One is that we need to be able to handle scalars. So this is not a string or a list of one character. Rather, it is a single scalar character without dimensions. And since this pairwise reduction needs to traverse a dimension, it fails as there aren't any dimensions to traverse. It's saying rank error. A scalar has rank 0, there are 0 dimensions, but we need at least one dimension, a vector, in order to do a reduction. We can fix this, however, by raveling. Raveling means taking all the elements that are there and, like a bunch of yarn, we ravel it, or even a sweater where you pull a loose thread, and it becomes a single dimensional list of the elements. And that is monetic comma. So it will appear the same, but this actually adds a dimension that we can then reduce over. So I doesn't have any, of course, and no one element word will ever have duplicate letters because there's only one there. Now that this is done, we need to fulfill the whole spec of the challenge, which is to handle multiple words. So I, of course, as we know, doesn't have any, and the doesn't have, but feed has, and bookkeeper has multiple duplicated letters. So we take this function that we have created, it just so happens that we can just parenthesize it and apply it to each one, and this works fine. One more catch is that we have to be able to handle a single word. So this is the each, and if we try to do this on a single word, then we get the wrong result. And that's because the each now traverses over the word itself and adds and applies the function to each letter. What we want to do here is, if we have a single word, we want to enclose it. But if we have multiple words, then we don't want to enclose it, to treat it as a whole. And for that, we have a very convenient function that is often called enclose if simple, or just nest, is because it does exactly this. It encloses if the argument is simple. So this is a simple single word, and it will then enclose it. But if we have multiple, then it will not enclose it. We spell it like this. It's the enclose symbol with an extra underbar, also called nest, because it guarantees that your result will be nested. If it isn't already, it will add an outer enclosure. So now we get the right result here, and if we try to do it over here, then we can see which words are have duplicates and which ones do not. And so this whole thing, we can just go and give a name. And now we can apply it on both lists of words and single words. Thank you for watching.